Hello friends. In today we'll learn what is crystallography, what is lattice, crystal lattice, and lattice translation vector.
Crystallography. Here, the word crystallography is made up of two words. One is crystal and another one is graphy. Here, crystals means it is a solid material whose constituents are arranged in orderly to form a structure. And graphy. The word graphy means to study. So in general we can say crystallography is the branch of science of determining the arrangement of atoms or ions or molecules in crystalline solids. Okay, or its particular definition is crystallography, the branch of science that deals the arrangement and bonding of atoms in crystalline solids and with the geometric structure of crystal lattice. Means in crystallography, we study the arrangement of constituent particles like ions, atoms, or molecules, how they are arranged in a structure. So that one we call crystallography. Next, lattice. Okay. Now, to construct a structure of any element, we represent ion, molecules, or atoms as a point. Okay, and such points are called lattices. See a definition. The points in a crystal lattice in the model crystal represent the positions of structural units like atoms, molecules, or ions. Okay. In general, we can say lattice means representation of atom, molecule, or ions as a point to construct the crystal structure. Crystal lattice. Here, the crystal lattice is the geometrical pattern formed by the points and used to represent the positions of the elements in a structure. That one we call crystal lattice. Here, definition. Crystal lattice. The arrangement of atoms, molecules, or ions of a crystal in the form of space lattice. And the crystal lattice is the symmetrical three-dimensional structural arrangement of atoms, ions, or molecules inside a crystalline solid. Okay. And remember here, the crystalline, okay, the crystal lattice is the array of points at the corners of the structure or crystal structure. See here, here number of atoms are there. Okay, you can see here, yeah, number of atoms are there. And if you want to construct a crystal structure, so what we have to do? Points. Okay, we represent each atom as a point here. We are representing each atom or ion or molecule of some element as a point. These atoms we call base and we represent each atom as point. So this structure or this figure we call lattices. Now combine. So what we get? A structure or a three-dimensional structure. Here you can see a dark circle here. Okay, these circles or these dark points represent the atom, and these points we call lattice points. These are the lattice points. Okay, and each lattice points are connected with some line. Yeah, you can see a line. Okay, these lines we call lattice line. Lattice lines. So this structure which we obtain from bases means ions or molecules or atoms representing with as a point means lattice, and after combining bases and lattices we are getting a structure of. Finally, a crystal structure is obtained with the combination of bases plus lattice. Okay, you can see here a crystal is obtained with bases and lattice. Here bases represent the atoms, ions or molecules plus lattices. Okay, this is about crystal lattice. Come to next point, that is lattice translation vector. Lattice translation vectors are of three types. First one-dimensional lattice. In one-dimensional lattice, lattice points are linearly arranged. Okay, see here. You can see these dots we call lattice points, and they are linearly arranged. Okay, so this one we call one dimension lattice, and here see here A represents a distance between one lattice points 2 and the and this one we call translation. Next, two dimension lattice. Here you can see these lattice points are horizontal and these lattice points or lattices are vertical. Okay, now draw a vector one lattice point to another, say this one vector A, and draw one vertical vector, say this vector B. Okay, and this angle alpha represents the angle between vector A and vector B. Okay, and combine with the help of vector addition. Here we can write T represents translation vector is equal to n1a plus n2b, where A represents translation vector A along translation axis, say this one x axis, and B represents translation along y-axis. Then with the help of translation vector addition, we can write translation vector T is equal to n1a plus n2b, where n1 and n2 are the two integers. In two-dimensional lattice, the translation A is combined with translation B, then a two-dimensional array is obtained, and the corresponding collection of points is called a two-dimensional or a lattice plane. Three-dimension lattice. In this, the plane pattern having repetition intervals, that is translation A and B, is combined with the third translation C. Then a three-dimensional array is obtained. The corresponding collection of points is called three-dimension or space lattice. See a figure. In this one, these black circles represents lattices, and these blue lines which you are seeing, these are the lattice lines. Okay, and the region between these lattice points, see, this region called lattice plane. This one called lattice plane. Okay, and in this three-dimensional lattice, x represents translation direction or crystallographic axis x, y, and z. Here alpha, beta, gamma are the angles made by the crystallographic axis x, y, and z. And here A is translation along x, B along y, C along z. Now translation vector is T equal to n1a plus n2b plus n3c, where n1, n2, n3 are the integers and a, b, c are the translation along x, y, and z.
Okay, now this is about crystallography, lattice, crystal lattice, and translation vectors. In next session, we discuss what is unit cell and their types. Thank you.